Hi, and welcome to this intro tutorial video programming robots in MachineLogic using scene assets. I'll be using the design that we see on screen over here, which is a FANUC CRX machine tending cell. Our primary goal is to create a simple pick-and-place application that will pick up the part on the left and drop it off at the location on the right. Now, for any of the terminology that I use today, you can always refer back to our robot programming and scene assets MachineLogic guide that can be found in our MachineLogic section of the Resource Center. Now, to get started, we'll have to open up the MachineLogic tab. In order to do so, you do have to have a machine motion controller in your design, in our case, which we already do. So let's open up the MachineLogic tab and get started on the first step. You'll see on the right side, we have this new window called Scene Assets. This is where we will be spending the majority of our video. However, to gain access to its full feature set, we'll have to configure our robot first. To do that, we'll go over to the bottom left-hand corner of the screen and select Add Robot. The software will scan through your design, seeing what robot, as well as what end-of-arm tool you have in your design. In our case, we have the FANUC CRX 10IAL with an on-robot 3-finger gripper attached. The first major step you have to do is simply rename your robot that will be used later on in your program. I'll rename ours FANUC CRX. Now below this, you'll notice there are a few input windows for the tool center position. If you're using one of Vention's default grippers that are available in our parts library, it will automatically fill out the default values, in our case, with a Z offset of 155.03 millimeters. If you're using a custom end-of-arm tool, you can override these values by simply inputting a value in each of the windows. If you want to go back to the default, simply select Use CAD Default. In our case, gripper has already been pre-configured to be triggered via our digital I/O. Now that this is done, we can finish off the configuration step, close the MachineLogic window so we can gain a full access view of the design, and we can move on to the scene assets portion of this video. Now over here, this is where you'll be creating your calibration frames, your reference frames, Cartesian targets, joint targets that will later be used within your MachineLogic program. Each of these can be used as global assets, which means they can be used across multiple different applications within the same design. In our case, we'll be first focusing on the creation of a calibration frame. So essentially, calibration frame can be thought of as a reference frame defined relative to the robot base. The position of this frame we will be creating is nominally defined in the scene or in your design and is expected to be taught in the physical world afterwards. So this is the point that your targets that we'll be creating later on will be referencing your 3D model over here. Since we'll be using a digital twin, which is a one-for-one recreation of what you have in real life, it's always good to choose a point in space that is close to the targets that you're going to be using or going to be creating later on. In our case, our goal is to create a reference frame at the corner of our first part tray in the top right corner. To create one, you'll go over to the right, click on the plus icon, and select Calibration Frame. It will automatically default to the base of the robot. However, you have 3 different methods to move it around in your design space. The first is to use the triad that you see on screen over here that functions similar to the one that you use in Machine Builder. You can use the squares to move in a specific plane, arrow keys to move in a specific axis, and the curved surfaces over here to rotate around a specific axis as well. The second way is to input specific values in the windows in the bottom right-hand corner. This will then move your triad to a specific location within the 3D environment. The final, I'd say most easy way to do this is to use the point-to-point tool. This function is very similar to the point-to-point connection tool in Machine Builder. However, it lets you choose any arbitrary point in your 3D space. So we'll select point-to-point and then zoom into the location that we want to create our calibration frame on. Clicking the corner over here, I can confirm, and then it's always good to rename it so you can reference it later on when you're creating your program. In our case, I will call this Part Tray 1. I'll click Save to confirm, and then simply zoom out to get a better view of my full design. Now that we've created our first calibration frame, the next thing we want to do is create some robot targets. Now there are 2 different robot target types that you can create. The first one being a Cartesian target, which is a point in space the robot will attempt to reach when it's called with MachineLogic program. And the second is a joint target, which indicates the specific joint angles that you want your robot to have when achieving its position. this is the one that we'll be creating first, as we want to create a home position with a repeatable robot position. So I'll select Joint Target from the plus icon in the drop-down menu. Now over here, there are again 3 different methods that you can teach this position. The first is by using the triad at the end of the robot to move the robot to a specific location. The second is using the sliders in the bottom right-hand corner. And the final is by inputting a specific degree angle at each of the joint window inputs. So in this case, let's set it back to 10 degrees. And then we will rename our joint target as home as originally intended. Click Save to confirm. With our home position saved using a robot joint target, let's move on to the creation of our Cartesian targets that will be used as the pickup and drop-off target points for a pick-and-place application. In our case, let's zoom in on the part we want to create these waypoints around to make it a little bit easier. Now, when you're creating your Cartesian target, they're always created with respect to a specific calibration or reference frame. In our case, we'll be creating them with respect to the part tray 1 calibration frame that we created earlier. Our goal, create 2 different Cartesian targets. The first one being at the top of the part itself. Second, just above it as an approach position for the robot. Now, in order to create one, all you have to do is select the reference frame you want to create it on. In our case, part tray 1. Right-click and select Cartesian target. Now, to move the Cartesian target around in 3D space, the exact same as when you're creating a calibration or reference frame. Either dragging the triad around, inputting specific values in the windows, and using the point-to-point connection. You'll notice that it has the default values of 0 across the board, always gets created at the same position as your parent reference frame. Now, we'll be using the point-to-point tool since it is the easiest one to use in our case, and attach it to the top of the part that we have over here. With that, I can rename the target as pick part and press save. Now, my goal is to create a secondary target point that is a couple centimeters above the part itself. Now, I can create a new Cartesian target by right-clicking and selecting Cartesian target. However, there's a chance I won't be in the exact same position in the XY plane. To get around this, I can always duplicate a Cartesian target that's already created by right-clicking and selecting duplicate. In this case, it will create it the exact same position as my parent Cartesian target, and all I have to do is drag the Z slider to have it rest a couple centimeters above. With this, I'll rename this to part approach and press save. Now with this, we've created the approach points for the picking up of the part, and now we have to do the secondary ones for dropping it off. I'll zoom back out to the full screen view of my design to get a better view of what we can do from here. Now there are a few different options that we can go through for creating the place position for the part on the right over here. Create a brand new calibration frame, place it at the bottom right corner over here, create brand new Cartesian targets, and follow the exact same steps that we did earlier. Or we can do this in a single step by simply duplicating the entire frame as well as the Cartesian targets in one act. Do this by right-clicking on the original calibration frame we created and select Duplicate. Now from here, all we have to do is edit position. Since the part is placed in the exact same location between the 2 trays with respect to their respective corners, I can simply select point to point, zoom in, and place my new calibration frame that I just duplicated. You can see it brings over the exact same Cartesian targets above the placed part. Only thing I need to do is rename. We'll rename this part tray 2. From there, I'll save, zoom out, and we've finished with the scene assets that we need to create this pick and place application, and we can move on to programming our robot. To do this, let's bring the MachineLogic window back and change over to our application. This is where we'll be creating the robot program itself, following the scene assets that were created earlier on. But before doing so, let's walk through the program that we want to create. We want to have our robot start off in its home position, move to the approach point for picking up a part, pick up the part, go through the approach point, through home, and then repeat the process but in reverse for the place part. So place part approach, place part, drop it off itself, and then probably go to home for the end. Now that we know what we want our program to do, let's actually build it out. We're going to start off by adding the first few robot commands. So we'll go over to Add Command, select Add Robot Move, and this is what will pop up. We know we need 3 separate robot commands before we do an output command. So we'll add 3 different targets. One for the home, one for the approach point, and one for the pick point itself. Now for the drop-down menu, you'll notice that all of the ones that we have over here are the same that are found in our scene assets. So anytime you create a new scene asset as a robot position, a robot target, this is will be found in your MachineLogic commands. So we'll start off with the home. The second one will be the pick part approach, and the final will be the pick part. Now, if you want to make sure you are selecting the right command as you're going through the creation of your program, you can always select here to validate that you have selected the right point. In this case, I've cycled through the home, pick part approach, and pick part. I'll move the robot back to home just to avoid any singularities once I do play the program later on. You'll notice that under each of the robot targets, there's a drop-down menu called Motion Parameters. Expanding this, you'll see 3 different windows. The first is Speed, Acceleration, and finally Blend Radius. These allow you to edit the speed and acceleration of the robot as it transitions from one point to another. The blend radius, I'll leave as 0 for now and talk a little bit more afterwards. You also have the option to change the move type. The 2 options available right now are Move J's and Move L's. Primary difference is that Move L will have the end of arm tool, or the tool center point of the robot, in a linear fashion, whereas J will just make sure that the end of arm tool ends up at that Cartesian target, regardless of the path that it takes. In my case, I want to have the final move be a Move L to ensure that the robot goes in a linear path from the pick part approach position to the pick part position. Now let's add the actual commands in MachineLogic for the actuation of the gripper. So we'll add an output and a wait command to ensure that the gripper has enough time to fully grip onto the part. For the digital output, we'll change the value to 1 to actually grip and change the wait to 350 milliseconds. Now from here, we're going to add the rest of the robot moves before the drop-off position to go through the pick part approach point, home position, place part approach point, and then place part. So that's going to be 1, 2, 3, 4 different robot moves that we'll have under one robot move command. So we'll add commands, select Add Robot Move, and add 1, 2, 3, and 4, and then select the correct ones. So we're already at the pick part position. So we're going to do pick part approach, home, place part approach, and place part. We can also add the final 2 commands for dropping off the part at this time as well. We'll add command, add an output and a wait, and then have the gripper value be 0 to actually let go. And again, let's do 350 milliseconds. This is where I want to touch on the blend radius found under the motion parameters. So what I'll do is find the secondary time passes through the pick part approach point, which will be over here. Open up motion parameters and edit the blend radius. I'll change this to 0 or from 0 to 50. What the blend radius does, it allows the robot to pass near the point without actually having to go through it or stop at the point itself. This allows you to have a much smoother program. So rather than having the robot go from the approach point to the pick point, back up to the approach, and then over to home, it's able to go from approach to pick, pass through the secondary approach, pass directly to the home. Allows to create a much smoother, streamlined, and faster program overall. Now for the rest, I'll leave the speed and acceleration as is, and add on the final robot command to move it back home. So add robot commands, select Add Robot Move, and do 2 new targets. One will be for the place part approach, again, adding a small blend radius, and then the final to move back to home. And with this, I can press play to see my program simulate. Press play, and then I'll move the Scene Assets window out of the way so we can actually see the program run. And that concludes our tutorial for the introduction to robot programming in MachineLogic using Scene Assets. Thank you for watching, and please check out the other videos in our resource center.